Time crystals. Are we about to go back to the future? Let us begin. Time has famously been a very hard topic for our minds to grapple with. We're fine with the three dimensions, width, breadth and depth, because we have agency in those dimensions. But time, the fourth dimension, seems to be pushing us irrevocably to our ultimate demise. And that scares us. Well, some of us. And now scientists have successfully created time crystals. And to quickly answer the question about going back to the future, no, we won't be. I should apologise for the bit of clickbait, but for your time, I can promise that I will make you think and show you that my opinion about time just might be right. So first, what is time? Time is the process that forces state A to move to state B. Simple. I can freeze time, quite literally, by sticking you in the freezer. The process of moving from state A to state B is halted, for a time at least. But obviously this will also kill you. And of course time would move around you, so we haven't really frozen time, we've just slowed the amount your atoms are affected by time. But then I could send you at the speed of light. This again will kill you, but time for you would slow down as per Einstein's special theory of relativity. Then I can either send you up a mountain or just closer to the equator, which will both speed time for you. Or I could send you down a hole, closer to the Earth's centre and closer to the source of Earth's gravitational effects, which will slow time down for you. This has been proven by sending an atomic clock up in space and keeping another on Earth. The reason why we see the same effect at the equator is because the Earth bulges there, and so you would be farther from its centre there. Just a quick lesson on atomic clocks. Basically, they use radio waves at a frequency of around 9 billion cycles per second. This frequency makes cesium atoms oscillate or give a little jig. When these atoms jig, we know we have the right frequency, which is around 9 billion cycles per second, and a certain amount of the atoms will reach a sensor. So a second is how long it takes for the peaks of radio waves to pass a point around about 9 billion times. We merely use cesium atoms to check we have the right frequency in a constant feedback loop. If an atomic clock speeds up in space, meaning to say the time it keeps speeds up, it's because it is farther away from the gravitational effects on Earth. This means time is a physical force, closely related to gravity, probably in a similar way that electricity and magnetism are two elements of the same thing, electromagnetism. Shout out to my fellow Londoner for that one, Mr. Michael Faraday. Anyway, what we are witnessing with the atomic clocks when that clock speeds up is the amount of time it takes for the peaks of radio waves to pass a single point 9 billion times. That's all. Imagine you were a submarine going through thick swamp, and then imagine that same submarine going through clear water. It seems this is the same thing that is happening here. The radio waves pass more easily when farther from Earth's gravity, which means closer to the Earth's gravity, something is holding it back. And what that something may be is the warping of space itself. So the more space is warped, the longer it takes for processes to get from point A to point B. If we flatten space out, it has less space to move through, even though in both circumstances they travel at the same subjective speed. But why does time always flow in one direction? What's stopping it from flowing back the way? Well, maybe, just maybe, wherever space is warping into, in that part of the universe, time is flowing the other way, meaning to say that time is following the expansion of the universe. So our bit that is expanding sends time one way, and the other part of the universe that is contracting is sending time the other way. But I actually don't agree with the reasoning behind expansion of space, but that's for another video. So, time crystals. A crystal is a structure that repeats itself, like a diamond. The carbon atoms of a diamond repeat in a lattice. Time crystals are atoms that are in constant motion and repeat their movements over time. These are not things you can hold in your hands. These are, in some cases, tens of atoms, and a human hair is 1 million carbon atoms wide. But time crystals need no input of energy, and they don't expel energy, very unlike our radio waves in the atomic clock. Please let me quote from a Scientific American article. The link is in the description. In 2012, a physicist that we're going to call Frank, because I'm not going to butcher his last name, at the Massachusetts Institute of Technology, noticed that the laws of physics also have a time symmetry. That means any experiment repeated at a later time should produce the same results. Frank made an analogy to normal crystals, but in the dimension of time, dubbing this spontaneous symmetry breaking through time a time crystal. A few years later, physicists were able to finally build one. Now, please allow me to conject, which is a posh word for chat shit, just for one moment. Maybe the force that is making them move is that which gives time its direction. I quote the same article. A time crystal keeps moving and repeats itself periodically in time in the absence of external encouragement, said Alty. This is possible because the time crystal is in its lowest energy state. The basic rules of quantum mechanics prevent the motion from becoming completely still, and so the time crystal remains stuck in its never-ending cycle. Maybe the real reason we can never force atoms to be completely still is because of the constant push of time. Maybe this push of time is inversely proportional to its position in the gravitational field, meaning the stronger the gravity, the slower time is allowed to flow, or the less force it has. The less force gravity has, the more time is allowed to flow. As there are no other forces acting on the time crystal that would not be considered a constant, if we were to change the rate at which they move by moving them up a mountain, we could be pretty sure they are under the effects of only time, although I should say time and the absence of gravity. But far more interestingly, we can start playing about with processes that may speed or slow the time crystals artificially, without having to put them up a mountain. I have a strong feeling that it will be experiments relating to time crystals that may take us back to the future and enable faster than light travel. If not, then what they will certainly do is bring the dawn of commercial quantum computers one giant leap closer.